Imagine building a spacecraft in an era before the internet, before smartphones, before personal computers became part of everyday life. Now imagine that same spacecraft continuing to operate nearly 50 years later, traveling farther from Earth than anything humanity has ever created. That isn't science fiction. It's the remarkable story of Voyager 1. At this very moment, Voyager 1 is racing through the darkness of interstellar space, billions of miles from our planet. Every signal it sends takes many hours to reach Earth, carrying information from a region that no human has ever visited. It has become much more than a spacecraft. It is humanity's most distant explorer. When Voyager 1 launched in September 1977, no one expected it to become a record-breaking mission. Engineers designed it to study the giant planets of our solar system before eventually falling silent. Instead, it outlived its original mission by decades. Its journey continues today, making discoveries that scientists could only dream about when it first left Earth. But none of this would have been possible without a rare event happening high above our heads. During the late 1960s, astronomers realized something extraordinary. Jupiter, Saturn, Uranus, and Neptune were moving into a rare alignment that happens only about once every 176 years. This unique arrangement created an opportunity unlike any before. A single spacecraft could visit multiple planets by using their gravity as a natural source of acceleration. Instead of carrying enormous amounts of extra fuel, the spacecraft could steal a tiny fraction of a planet's orbital energy. This technique is known as a gravity assist. Imagine throwing a ball at a moving train. If everything happens at just the right angle, the ball flies away much faster than before. Voyager used the same principle on a cosmic scale. As it passed close to a giant planet, gravity pulled the spacecraft inward before slinging it back into space at tremendous speed. This clever maneuver allowed Voyager to travel farther and faster than engineers could have achieved using rockets alone. Recognizing this once-in-a-lifetime opportunity, NASA launched two nearly identical spacecraft. Voyager 2 lifted off first. Voyager 1 followed just over 2 weeks later, but it was placed on a faster path that allowed it to reach Jupiter before its twin. The gamble paid off. When Voyager arrived at Jupiter in 1979, it transformed planetary science forever. Its cameras revealed details no telescope on Earth had ever seen. Towering storms swirled through Jupiter's atmosphere. Lightning flashed inside enormous clouds. And then came one of the mission's greatest surprises. Scientists discovered active volcanoes erupting across the surface of Io. It was the first time volcanic activity had ever been observed beyond Earth. The discovery completely changed our understanding of how moons could evolve. Another moon proved just as fascinating. Europa appeared smooth and icy, covered by long cracks stretching across its frozen surface. Today, many scientists believe a vast ocean may exist beneath that icy shell, making Europa one of the most promising places to search for conditions that could support life. After leaving Jupiter behind, Voyager continued toward Saturn. There, it delivered breathtaking images of the planet's magnificent rings with a level of detail never seen before. Instead of appearing as simple bands, the rings were revealed to contain thousands of delicate structures shaped by gravity and tiny hidden moons. Saturn's largest moon, Titan, also attracted enormous scientific interest. Although its thick atmosphere prevented Voyager from seeing the surface, the spacecraft confirmed that Titan possessed a dense nitrogen-rich atmosphere unlike any other moon in the solar system. Meanwhile, Voyager 2 continued exploring even farther. Years later, it became the first, and so far only, spacecraft to visit Uranus and Neptune. Those encounters revealed strange magnetic fields, powerful storms, and entirely new worlds unlike anything scientists expected. Together, the Voyager missions completely rewrote textbooks about the outer solar system. Yet their greatest adventure was still ahead. After completing their planetary exploration, both spacecraft continued toward the invisible edge of the Sun's influence. Beyond that boundary lay a place no spacecraft had ever reached before. A place where our solar system slowly gives way to the vast ocean between the stars. And what Voyager found there would surprise scientists all over again. After completing its historic tour of the giant planets, Voyager 1 faced a destination no spacecraft had ever reached. It wasn't heading toward another planet. It wasn't searching for a distant moon. Its next goal was something invisible. The boundary separating our solar system from the vast ocean of interstellar space. For decades, scientists knew the Sun created an enormous protective bubble around the planets. This bubble, called the heliosphere, forms as the solar wind, a continuous stream of charged particles flowing from the Sun, pushes outward against the gas and magnetic fields of our galaxy. Inside this bubble, the Sun dominates the local space environment. Beyond it begins interstellar space. But no one knew exactly where that boundary was located. The only way to find it was to keep traveling. Year after year, Voyager moved farther into the darkness. Its instruments continuously measured magnetic fields, energetic particles, and plasma surrounding the spacecraft. Then, in 2012, everything changed. The spacecraft detected a dramatic drop in particles flowing from the Sun. At the same time, high-energy cosmic rays arriving from deep within the Milky Way suddenly became much more intense. Another instrument recorded a sharp increase in plasma density. Together, these observations convinced scientists that Voyager had crossed the heliopause, the outer edge of the Sun's protective bubble. For the first time in history, a human-made object had entered interstellar space. It was one of the greatest milestones in space exploration. Yet the biggest surprise came afterward. Researchers expected the magnetic field beyond the heliopause to point in a very different direction from the one inside the solar system. Instead, Voyager measured magnetic fields that remained surprisingly similar. The discovery puzzled scientists around the world. It suggested that the boundary between our solar system and interstellar space was not a simple dividing line. Instead, it appeared to be a far more complicated region where the Sun's influence and the galaxy's magnetic environment interact in unexpected ways. Years later, Voyager 2 crossed the heliopause as well. Although its path through space was different, many of its measurements supported Voyager 1's discoveries while revealing important differences in the structure of the boundary. Together, the two spacecraft provided humanity's first direct look at a region that had existed only in computer models. The mission also changed our understanding of interstellar space itself. Many people imagine the space between stars as completely empty. Voyager showed otherwise. Even far beyond the planets, space contains thin clouds of charged particles, invisible magnetic fields, and energetic cosmic rays constantly moving through the galaxy. It is quiet by human standards. But it is far from empty. Today, Voyager 1 continues drifting farther from Earth at incredible speed. Its power supply slowly weakens each year, forcing mission engineers to switch off scientific instruments one at a time to conserve energy. Eventually, there will come a day when the spacecraft can no longer communicate. Its final transmission will travel across billions of miles before reaching Earth. Then, for the first time since 1977, Voyager will fall silent. But its journey will not end. Long after every instrument has shut down, the spacecraft will continue orbiting the center of the Milky Way for millions of years. Attached to its side is the famous Golden Record, a time capsule carrying greetings in dozens of languages, music from around the world, sounds from nature, and images that represent life on Earth. Whether another civilization ever discovers it remains unknown. Perhaps no one ever will. Or perhaps, in a future beyond imagination, Voyager will become the first introduction our planet ever makes to another intelligence. Until then, humanity's most distant explorer continues its endless voyage through the stars. A silent ambassador carrying the story of one small world that dared to reach beyond its home. And in doing so, forever changed our understanding of the universe.